petrochemical industry uses P&ID.
Yeah. You don't. You see that,
my friend. They use it for design, for operation, and for safety. How does it mean? During their design phase, P&ID are used to design the layout of chemical plants, including the placement of reactors, distillation, column, storage tank, and piping system. All those component equipment, they use P&ID to be. Then during the operation, after designing, after they have commissioned the project, when it's time for operation, they also use this P&ID to teach their operators as well as their maintenance team on how to go about their day-to-day activities. So indeed, we say operators refer to P&ID to understand the process flow, the control loops, and the interconnectivity of different world systems. They also use it to uphold their safety rules and regulations. P&ID help identify the location of safety valves, relief system, and other safety equipment, which is crucial for emergency response. Then in pharmaceutical industries, P&ID is also used in pharmaceutical industries, and this is how they use it. For compliances, they use P&ID to ensure compliance with good manufacturing practices, GMP, and other regulatory requirements in the pharmaceutical industry. For validation, they use P&ID for validation. P&Ids are used to validate the design and operation of pharmaceutical manufacturing processes. The maintenance, technicians refer to the P&Ids to locate equipment and understand system configuration during maintenance activities. Then in food and beverage industry, we also use P&ID. In the food and beverage industry, come on, go now. Sorry. They use, in the area of sanitation, they use P&ID help in designing and maintaining sanitary piping systems for food and beverage. He has gone out to I'm not asking, it's disconnected. Just hold on, let me reconnect again. It's not there anymore. That means it's not, I know it's meant to.
Oh, we can hear you.
Stay here. But it's not. Just hold on, let me reconnect. Let me reshare. It's back a bit, but it has not shared. So I should open it first. There you go. Okay. So
your screen is
let's see. Don't wait. I'm trying to link it up again. It's not pulling up yet. Come out.
It's up now.
Can you see my screen now?
Yes,
Hello?
please.
Oh, yes. So the third one is food and beverage industry. How do they benefit from P&ID? In the area of sanitation, to trace in case of defects in their food and other things they have sent to the market, they can use P&ID to trace if there's any defects. They use to measure efficiency. So in area of sanitation, I said P&ID and beverage processing in the of the process flow, which is the issue. I can remember, okay, in that connection, operators can optimize production efficiency and minimize work downtime. In the area of power generation, in power generation industry, they also benefit from P&ID. How do you do that? What is this? In the area of power generation, they in design, in safety, and in maintenance. So every company, the way they approach their P&ID is unique. Sometimes it's what company specific. So now the P&ID are used to design the layout of power generation facilities, including the placement of boilers, turbines, and auxiliary system. Safety aspect of it, P&Ids help identify the locations of safety devices such as relief valves and emergency shutdown systems, which are critical for the safety of operations. Then maintenance, technicians refer to P&Ids to locate equipment and understand system configurations during maintenance activities, such as boiler tubes replacement or turbine overhaul. The next set of companies that uses it most is oil and gas industry, the Baba of them all. So in the oil and gas industry, we use P&ID in design, we use it during operation, and we use it during maintenance. How is it used during design? P&Ids are used to design the layout of oil and gas processing facilities, including the placement of separation equipment, compressors, and storage tank, and every other equipment that are mentioned in the previous teaching. Then under operation, operators refer to P&Ids to understand the process flow, control loops, and the interconnectivity of different systems, which is crucial for efficient operation and work troubleshooting. The under maintenance, P&ID helps technicians locate equipment and understand system configuration during what maintenance. Activities such as pigging operations or equipment replacement. Then for aerospace, even aerospace, we use P&ID a lot. System design. During system design, P&IDs are essential in the design of complex aerospace systems, including fuel systems, hydraulic system, and environmental control system. They help engineers visualize the interconnections between various components, ensuring that systems operate efficiently and safely. Then number two, regulatory compliances. Aerospace projects require strict adherence towards safety and regulatory standards. P&ID aids in documenting compliance with these standards, which is critical for certification of aerospace processes. Maintenance and troubleshooting. P&ID serve as reference documents for maintenance personnel, helping them understand system layout and identify components during troubleshooting. Then in data processing, data centers. For cooling and power systems. In data centers, P&ID are used to design and manage cooling systems, power distribution, and backup systems. They illustrate how different systems interact, which is crucial for maintaining optimal operating conditions. The operational efficiency. By providing a clear overview of the infrastructure, P&IDs help in optimizing workflows and improving maintenance strategies, ultimately enhancing operational efficiency. The next area, the disaster control or disaster recovery plan. P&IDs are integral for disaster recovery planning as the critical systems and their interdependencies, facilitating quick recovery during outage in the power system. In automotive, whether railway, whether in our charging process, P&IDs are used to design assembly lines, paint shops, and other process systems. They help visualize the flow of materials and integration of equipment. Then in the same way, we use P&ID to control quality in the manufacturing processes, ensuring that quality control measures are effectively implemented. Safety protocols. They are used to develop safety protocols by identifying potential hazards related to the fuel systems, electrical system, and other critical components. In the area of distribution and logistics, imagine that. Logistics and supply chain. P&IDs are used in designing distribution systems, including pipelines and conveyor systems to visualize the flow of products and materials. Efficiency improvement. They help identify bottlenecks and inefficiencies in distribution processes, enabling organizations to optimize their operations. Integration of systems. P&ID facilitates the integration of various distribution systems, ensuring that they work cohesively to meet operational goals. Then in the plastic industry, plastic and packaging. During process design, in the plastic and packaging industry, P&IDs are crucial for designing extrusion, molding, and packaging processes, providing a visual representation of equipment and flow. Regulatory compliance. They help ensure compliance with safety and environmental regulations by documenting processes and road control. Maintenance and upgrades. P&IDs serve as essential tools for maintenance teams, helping them understand system configuration and plan upgrade or modification. The fabricated metal. This one had to do with both like these are Jaguar system, like I see me and the rest of them. That's what I'm talking about. This fabricated metal, right? Manufacturing sector. Manufacturing system. P&Id are used to design systems for metal fabrication processes, including welding, cutting, and assembly lines, ensuring efficient workflow, safety and compliances. They help identify safety measures and regulatory compliances requirements for hazardous materials and processes used in metal fabrication. Operational support. P&Id provides operational support by helping technicians and operators understand the flow of materials and interconnections between different systems. The next one, that is the last one, right? So we have so far we have about 9 different companies, multinationals that uses P&Id. So it means you learning it now is not a waste. You have a bright future if you understand what we are doing right now. The use of P&Id. P&Ids are essential in process engineering as they visually represent the piping and instrumentation system within a process plant, showing how different components interact irrespective of industry. So this irrespective of industry, the P&Id are quite helpful in a variety of ways, such as 1, used for planning and construction plants; 2, used to operate the processes; 3, used for maintenance and modification of the process; 4, used in all production, manufacturing, servicing, and logistic companies, engineers and operators, technicians, procurement, warehouse and safety personnel; 5, used for hazard or probability study of plants; 6, used as a control document formally issued at various stages of the project. Then instrumentation symbol. I've talked about this yesterday. Do I need to talk about it again? Instrumentation symbols are more than just simple icons on a drawing. Each one carries a wealth of information that help engineers, technicians, and operators understand how a system works. To read and interpret these symbols correctly, it is important to understand their basic components. Let's break them down. Geometric shape. Instrument symbols usually begin with a basic shape which indicates the type of and location of the instrument. When they are circle represents a field-mounted instrument installed directly on the process line. Square indicates an instrument located in a control room or panel. Hexagon or diamond. There's a rectangle that is start working. That is a rectangle that is actually start working. Is standing with the tip. Instead of standing flat, that is hexagon or diamond. May represent logic functions or functional integration. Inside or near the symbols, you will typically find a set of capital letters that are not components in instrumentation. This follows the traditional standard of letter identification. The first letter indicates the measure variable. That if you have a letter in your circle, that first letter is always what the measure variable or the parameter. That is what we want to know. Most times there are more than 4, they are very big, but we choose to pick only 4. Temperature, pressure, flow, and what level. I think temperature, pressure, flow, and level. Subsequent letters shows the function. They have shade and that function. That is the indicator. Oh my God. I stand indicator for the next alphabet after the first alphabet, then the second alphabet. Then T and the second alphabet, if you follow a T in the second alphabet, it's no longer temperature, it's now transmitter. That's instruments. Why the first T, the second T, which is transmitter, belong to the instrument group, controller and the recorder. So in the instrument group, we'll talk about 4 to indicator, transmitter, recorder, and controller. Examples: if you have a P means pressure, I means indicator, T means what? Transmitter. So you are right to say pressure indicator transmitter or pressure indicating transmitter rather. Then this LIC is just level indicator transmitter or rather controller or level indicator indicating controller. This TIR manual transmitter is now this letter temperature indicating recorder, or then this TIT, this first T is temperature indicating transmitter. You don't call this transmitter indicating temperature, it's wrong. It's temperature first indicating transmitter, right? The next page. Note the first letter is always among these four parameters and must not be misrepresented. The first is out. Note the second and the third letter is always among these four parameters and must not also be misrepresented. Indicator, transmitter, controller, and recorder. All right. Example in TIT, the first T represents temperature, not transmitter. The first letter represents the parameter to be measured. The second letter represents the function of the instrument, while the third letter represents the instruments. So here now, this